Yeah, whenever you want. Yeah. Yeah, we are on the stream. We are on camera.
Okay.
Everyone. Yeah.
Okay, cool. Hello, everyone.
Yeah, just yell it down.
Yeah.
Hello, hello. Hi.
Hi. Hello, everyone. Okay, so, I think how many of you guys know that it's Godiva week? You guys know it's Godiva week? Okay. Yeah, so a lot of events. Check the official blue and gold website for all the events. Included in that is the chariot race for the. You guys are all the first year chariot race. The Anxiety chariot team sucks. We want to crush them. Okay. So construction is 9 to 11 every day of Godiva week. It is in the track 1 common room, which is right by SF 1115. So today we did some setup, but every day until Friday with the races at 4:15 at Queens Park, we will be doing prep for the chariot race. So pull up. It's gonna be great. We need to crush the insights. We need to beat them so bad. They keep on winning.
All right. Good luck with that. All right. All right. Thank you. All right. Okay. All right. Cool. Okay. Hi. Nice seeing everyone. Nice winter day today. So a good day to start the term. So the marks are not out yet. I don't think for any of your classes. The reason is they need to be approved by the undergraduate assessment committee. When that happens, possibly this afternoon, possibly after, not in my control anymore. So you'll get them when you get them. I did submit them. So that's that. I wanted to give prizes for the Pong. So there are a bunch of nice submissions. So let's see. Are the gold and silver medalists over here? Coming up. I'll. Okay. All right. So the gold. Sorry, I don't know people's names. So the gold medal goes for Grant and Vincent. Someone take photos or something? That's okay. Okay. Are you the silver medalist?
Yes, sir.
All right. So Hugo and Sebastian.
Yep.
All right, and I'll pull up the game between you guys just now. So, this is like a game. So the you know, 100 to make sure that we are fair.
I didn't say what are you talking about?
All right, and then the winner of the match here is going to play against Killen, who contributed his code yesterday.
Oh.
I don't know what.
Yeah, that's good.
You guys look
Thank you.
okay. Yeah, I'll send it to you, Professor K, guys.
Thank you very much.
Because I don't know what your email. I can send it to you alone.
You want to watch?
Can you put it like?
Say it.
If she sends it to you, can you put it in the?
Yeah, well, yeah. All right, sorry. So we'll do the game, and then I'll give everyone else their certificates as well. Hold on. All right. Oh. All right, so gold is going to be on the left, and silver is going to be on the right.
guess not.
Hold on. Sorry, just one sec. Oh. All right. So gold is on the left, silver to 5 points. Yeah, that's the magic battle. I had to fix it up so that it's playable, and that's like one of the things. Ooh, exciting. Hey, congratulations. All right, and the next challenge is for gold. I did not try it, so gold is gonna play Super TA Kill-In. We'll see how that goes. All right. In the meantime, the bronze medalists. So there were several teams that were very close. So Vedant, Javier, Arvar, and Muhammad, and Arvar and Muhammad. If anyone is here, please come pick up your stuff. Vedant, Javier, Arvar, and Muhammad. Okay, some people are here. All right. Yeah. 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 Can you take a picture? Yeah. All right. How's the gold team doing? That's okay. You want to put that?
Yeah.
Okay, and can you give it to me? And then I have 5 honorable mentions unannounced. Everyone got the point. Declan Chan, Alex Wong, Wang, sorry, Yiming Lu, or Zhang. Anyone is here? Yep. Yeah. You want to- Take care. Hey, Steven.
Yeah.
Thank you very much. Cool. Okay. All right. Thank you. We're starting the class. Oh, why did they stop sharing? So the website is like /190 run /180. So just the syllabus also kind of looks the same. So the labs start on week 2. So no lab today if you are planning for one. We did not end up having online labs. We will have online labs this time around, especially because there's just 2 projects rather than 3. There's just like, it's hard to fit in 3 projects into the winter semester, so not trying. The midterm actually kind of similar. So actually, I believe says like right after reading week again. So I think it worked out well. People had time to prepare. Quizzes work the same way. Yeah, so, that's all the same. My office hours are tentatively Wednesday 6 p.m. and then well, I'm considering moving those and having the catch-up session during that time. We'll see what they can book. So there will be a catch-up session for the lab as well. So in terms of textbooks, so we did not really have a textbook for 180, in part because it was like a weird kind of course in terms of what's done elsewhere. 190 is also not exactly standard because it's Angsci, but we will have kind of more textbooks. So the King textbook is what I recommend if basically you feel like you're behind. So the King textbook is what we used to use in ESC 180 back when ESC 180 wasn't the C programming language. So that's like the introductory book that's like completely from scratch. 190, of course, assumes that you've passed 180. Hopefully all of you did. I think everyone, I think like one person did not maybe. But if they didn't, they're not in this class. This book is, it's a classic. It was written by Brian Kernighan and Dennis Ritchie. Brian Kernighan, arguably one of the more famous Angscis ever. So that's nice. And the C programming language is one of the most famous textbooks ever. So it fits. At the same time, as I read this book, I say, okay, is it a great fit for, second semester, first year? Arguably not. It's not really a textbook. It's more like a manual, and it's more like an introduction to like the culture of writing C in the 1970s, 1980s. So it's an interesting historical document. It's fun to read just because they show you all those tricks that they came up with. At the same time, is it like a straightforward textbook? Well, no, it was never meant to be. So get the book, read it if you like, see if that's the kind of thing that you like. Some people are really into it. Some people think it's the best book ever. Maybe that's you. You won't know if you don't try. At the same time, that's not the course textbook. I will sometimes refer to examples from it, but sometimes I will say, this is an example from Kernighan and Ritchie, and it's a terrible example that nobody should follow. So that's like that. So what else is going on? They close the syllabus. The Skiana book, the algorithm design manual, that's not relevant for now. So that's gonna start being relevant around week 7. I don't think it's an ideal textbook, but it is the best thing that was actually printed as a textbook for this class. So it's basically a bunch of examples that are actually implemented in C. So what it's good for, again, starting week 7, once you know C, and once we start doing algorithms, is if you want to see a really big worked example, and then another one, and then another one, and then another one, that's good for that. So we also, together with the TAs, are developing a set of lecture notes. So last year's are online, so they're linked from the calendar. We are going to be redeveloping them as well. So now, unlike last year, I have all the transcripts of all the lectures. I don't know if you noticed, but if you go to YouTube and you go to like the lecture YouTube videos, you can now actually like chat with the videos. So you say like, I have a question about like what was said there, and it'll tell you the answer usually. So on the back end, I have the transcript of the lecture. So I can now very easily just adjust the lecture notes from last year to exactly what was happening in lecture this year after a couple hours after lecture once the YouTube transcript is ready. So I'm gonna be doing that. I'm gonna try to be verifying those so that there's no hallucinations. But yeah, technology is amazing and might replace me soon. Hopefully the way it'll replace is by looking at my materials so that anyone who asks ChatGPT gets my answers and not some AI answers, but you know. So, okay, all right. So that is that. And let's start the class. So welcome. The class name is a little bit weird. It's called Computer Algorithms and Data Structures. That's what you'll see on Acorn, I think. Or maybe Comp Algorithms, Data Structures. I think Acorn abbreviates it. It's a little bit weird because I don't know if there's algorithms that are not computer algorithms. And I don't know if there's data structures that are not data structures, but you know. Okay. So what we're trying to do here is we're going to basically, especially in the first couple of weeks, learn the C programming language. And then we'll learn more advanced algorithms, and we'll be implementing those algorithms using both Python and C. And when we're implementing in C, part of the goal is to just get used to C. So this week, and just now, we'll start writing in C. We'll start talking about the differences between C and Python. You will still be writing Python. You'll see why, but you'll all be writing C. So we will be writing C in VS Code. So VS Code is easy to install. C extensions for VS Code are easy to install. Unfortunately, MinGW on Windows, if you're using a Windows machine, is not necessarily easy to install. So if you can try it, hopefully it works. If it doesn't work, come to office hours, come to lab next week. We'll try to set you up. It unfortunately doesn't work on every laptop. On Mac, the situation is better. Just install developer tools. It's going to be fine. So for now, when I write C code, I just will write it on online GDB, which, like Python Tutor, lets you just write C and run it. All right. So just to show you what I mean. So again, so VS Code, just okay. So VS Code is going to look like this. So to install the C extensions, you'll press on this, and you'll search for the C extension like this. And then the internet is sluggish here, but once it shows up, yeah, this one, sorry. So just click this and install this. So you'll press install here. So on Mac, you want to install developer tools first. Just Google install Mac developer tools. On Windows, you need to install MinGW first, or it's not going to work. Unfortunately, on Windows, it's going to be an adventure, but it's going to be fine. All right. Okay. Not urgent. We will get everyone set up by next. So, okay, so we are going to be learning the C programming language. C looks a lot like Python because Python was developed as a kind of language that's kind of like C, but better. So it's a C-like language. But there's differences. So Python is, like we mentioned, I think like during the first week maybe of ESC190, Python is what's called a high-level interpreted language. So that means that Python is a program that, like Python.exe on Windows, is a program that takes Python code and then interprets the code and then it runs it. C is not like that. So C, you write the code and then you compile it. Compile means make it a program that you can just plug onto the hardware and make it run. So with Python, the software runs the code. With C, the hardware runs the code, would be kind of the simplified way of explaining it. So compile means take code and make it into something that's a simplified story. It's still kind of the software running it, but that's basically it. So why do that? Well, because it's run almost directly on the hardware rather than having this intermediate software that interprets the program. It can be much faster to run. At the same time, it can be much slower to write because it's lower level. You'll see why it is kind of more complicated. Okay. So why are we doing this now? Why not just stick to Python? Usually, like if you just solve it, no reason to see. However, sometimes you want for the thing to run fast, and Python is just not fast enough. C is faster. The other reason that we do it, and that's more the reason that we do it in second semester, first year, is that writing C programs has you think about the computer architecture. It has you think about what the hardware is really doing. And we need you to do this in order to prepare for second year when you'll be working even more directly with the hardware. So one of the reasons that it's like that, where we switch from Python to C, is we need to teach you about hardware. This is like not an introduction to hardware. I'll barely be talking about hardware, but it gets you closer to being able to work with hardware. And of course, nowadays, NVIDIA, Apple, things like that, those are actually hardware companies. So that's the kind of thing that you're interested in. You want to learn about hardware. So, okay, that was the motivation. I will now start talking about the C programming language. And part of it, and part of why Python is friendlier, is that right away I need to start talking about complicated stuff. So today is going to be more of an introduction. We are going to dive in and come around several times to explain what's going on. But first, I'll just write a hello world in online GDB. Don't actually need to write it because it was written for me. So that's the hello world in C. So I can run it. Need to say that it's actually C. Okay, it's dark mode now. Let me make it a little bit larger. You okay in the back with this font? Are you okay in the back? All right. So that's like this. So to print hello world, you use printf. You have semicolons at the end of every instruction. Those are mandatory. Unlike with Python, you cannot just write code, like you cannot say like print whatever over here. That does not work. It has to be inside the main function. The main function, you can think about it again as kind of like the main block, except now it's a function. It's declared like this. Unlike in Python, the indentation is just for readability. C doesn't care if it looks like this or like this. What C does care is that blocks of code are enclosed in curly braces, like so. Right? So if you want to print a number, that would look like this. So this is the same kind of thing. So comments in C, again, like we'll do all the syntax in an organized way later, but like there's no point in saying, okay, like this is a comment, this is this, this is this, this is this, without writing anything in the first place. So I'm writing some stuff just to start. So int is the type. So this is basically x equals 190 in Python, except in C you have there in C have to declare the type. So I have to say that x is going to be a variable that's of type int. And then x equals 190 is the same as in Python. The semicolon is mandatory. If I want to print x, I will print it like this. So here, this is kind of like an F string, arguably. So here, what I'm saying is substitute this, and D stands for decimal. I'm saying substitute this for this value. So if I run it, I have my x equals to 190. If I want to declare a string, I will declare it like this. So car star is kind of like a string. It's not quite a string, but I can print it. And I can print it like this. Okay, so this is kind of saying prof equals Evan Bentz, the way you would say it in Python. Car star is kind of saying that prof is a string, kind of. You'll see what I mean by kind of later. So here, in order to print it, I have to say that prof is a string. So the %s gets substituted with prof. So I can run it again. And I get prof Evan Bentz. All right. I need to figure out who your other profs are this semester. He's not actually teaching. Okay. Okay, makes sense? Questions so far? There really shouldn't be, because this is like nothing. This is just how it works. So, okay, let's talk a little bit about syntax. So So in C, every variable, like we said, needs to be declared. So you pre-specify what type of data is stored in the variable. So we saw an integer in the example in GTP Online. We saw double. So double stands for double precision floating point. So that's because C technically kind of has a float, but the float in C has fewer digits. So double precision means like many digits in the mantissa. So in Python, that is just called a float. There is a float in C. It is kind of like a double. It's just not as many digits. So car is a character. Some people say char. That's fine too. But because it stands for character, I say car. Some people do say char. So that's a character. So that's one single character. So unlike in Python, where double quotes and single quotes basically mean the same thing, in C, characters are in single quotes. So that's a particular data type. It's like one single character. Strings, which are not really strings, are in double quotes. So an example of a character is like the @ sign or B or whatever. So this is where things got complicated because I just said that car star is kind of a string. It's not. Car star is actually a number. It's the address of a car. So going back to the memory tables from Python, car star really is the address where the string is stored. It's not the string itself. So when I say, and again, we'll do it in much more detail, of course, but when I say car star prof is Evan Bentz, really what's happening, and we'll do it in much more detail, that's like the difficult thing here, is prof is the address where the E is stored. So that's really what's going on. This is the sense in which car star, by the way, the space doesn't matter. You can say car star like this. The usual style is to write it like this. Car star is the type. Some people write it like this, so to make sure that they know that car star is the type. This is just not the usual way that people write it. So when I say car star prof is Evan Bentz, what I'm saying is, just like in Python, put Evan Bentz somewhere and then make prof be the address of the E. All right. And we got to know this because we just started writing C and we already need to declare this variable and we already need to know what it means. So that's why C is complicated. But for now, this just runs, so there's no problem. Okay, so for now, that was details. It's gonna stop being details very soon. So similarly, you can have int star. Again, that's a type, and that type is an address. We'll see how that works later. So here's what strings look like in C. So first of all, they're not really strings. C does not have strings. So what C has is addresses. So the way the string hi is stored is like this. So if you store the string hi, what it really means is you store the character H, and then you store character I, and then you store a special character called the null character in sequence. So for example, if you want to store the string in quotes hi, starting at address 1032, the way it's going to happen is H is going to be here and I is going to be here, and then the null is going to be over here. Okay. the reason the null is there is that when I said prof equals Evan Benz, I did not actually take into account how many characters there are in the string Evan Benz, right? So what I did really is I stored EVA and space B and T, Z, and so on. And then I put a null there so that I know where the string is over. So when I go and I want to print hi, what I do is I print the H, and I print the I, and then I encounter the special null character, at which point I know that I can stop. What I store for hi is just 1032. Because I just store 1032, in order to know when the string stops, I need a special character that says, oh, like that's the end of the string. Does that make sense? So coming up later is I lied to you. Hi is not actually of type char star, it's of type const char star. We'll see that later. All right. So literals in C. So just a reminder, literal is a programming language term. Literal is data that is inputted directly into the code. So integers and doubles work the same as in Python. You put in a bunch of digits, that's an integer. You put in digits with a decimal point, that's now a double. Like we said, symbols in single quotes are of type char. Strings in double quotes are of type const. We'll talk about what const means later, char star. So the value of that is the address of the first character. Okay, so what I mean by this is the literal. This is a literal. So a literal is data that I can put into my code, right? And then each literal has a value. So the value of 190 is this. The value of this is the address where I decided to store the capital. Okay. So this is just like an overview of variable declarations. So int a equals 42 is something that we've seen. C has ints and it has long ints. So a long int is just an int that's allowed to have more digits than a regular int. How many depends on the computer actually. In order to input a long int, you have to have the capital L at the end. If you input too many digits in a row and claim it's an int, Python is going to complain. C is going to complain. Python is not. C is going to complain and say that's not a valid int. So not often that you need it, but you can do it. So long int is 2 words, but that's a type as well, in the same way that char star can have a space there. That's still just 1 unit in the same sense that you have char, you have int, you have long int, you have char star. Okay, so those are all types. Okay, so one new thing here is this. So I can say char star. So I use the letter P, it stands for pointer. So here what I'm doing is I'm saying I'm declaring a variable whose name is P_C. Its type is char star. And then this is a new thing. This is saying PC, its value is the address of C. So ampersand, so this is just like this character is called the ampersand. What it means is address of. So this is saying wherever you decided to store C, give me the address of that. and store that address in PC. Make sense? So let me just experiment with this a little bit. So this, by the way, is a way to comment out. Sorry, I didn't say that explicitly. So you can comment things like this. So this starts a comment in the same way that the pound sign starts a one-line comment in Python. So I'll have a C that's like that. So this is the character that's the @ sign. And now I'll have another variable. I'll call it PC. So I name it PC just because I know that that's what it means. That's just the name. It could be anything. And I'll say that's the address of C. Okay. So I can now print first just the character. So to print the character, I need to specify that I'm printing the character in the same way that here I needed to specify %d to print an integer, and here %s to print a string. To print a character, I do %c, and then I do new line just so that there is a new line at the end, and I print c, and that is going to print the @ sign like so. Okay. So I can also, and that's going to work slightly differently on different machines. I can print the address where the variable, the data in the variable C is stored. I'll do it like this. And I'll say I'm printing PC. So LD stands for long decimal, and that's just because it happens that you can convert this to a long decimal, and that's going to be the address. So that's the same as ID in Python. It tells you where the thing is, kind of. And the answer is the thing is over here. So this is the address in the memory table where this ampersand lives. Make sense? I can also do it directly. So I'll just say LD, and I'll say %c here. Those are, of course, the same because I said PC is equal to %c. So that's just going to print the same thing several times. Of course, on your machine, it's going to be different numbers. And even if I run it, I didn't notice if it was the same. It's not the same every time, right? Make sense? All right. So similarly, I can print prof like this. So if I print prof like this, what I get is the location of Evan Betts, or more specifically, the location of the E, right? So you'll notice that here I also printed prof, but here I said print prof and it's a string. Here I said print prof and it's an address. Really, prof is an address. It's just that when I specify it's a string, what it does is it goes to that address and it prints all the characters until it encounters the null. Make sense? So really the % thing specifies how to interpret the data that I'm sending to the function print. Does that make sense? So the instruction here is I'm giving you prof. Prof is always the address. And this is just saying, pretend it's an integer, print it. And it did that. Here it says, it's an address, print every character at that address until you encounter a null. Make sense? So, okay. So the next thing I want to do is arrays. So so an array is like a list. A list in Python is allowed to be heterogeneous. That means that you can have objects of different types in the list. Arrays in C, in fact, like NumPy arrays in Python, have to have the same type of elements everywhere. So you can declare an array like so. So here you say, I want an array. I want you to figure out how long it is based on how I initialize it. You initialize arrays in curly braces. This is just the syntax. So that works like this. Operating on elements of the array works the same. So you can say, I now want array at 0 to be 3. Array at 0 is going to be 3. You can say, I want an array R2 with elements that are of type int that has 10 elements, and that's going to be like this. One thing that's inconvenient about C is that this is not actually allowed. So you can do this when you're initializing an array. So that means when you first say this is a variable of type array of integers, you can initialize it, but you cannot say array is this something new. Okay, you can modify individual elements of the array. You cannot say array is this. There is a reason for that, which we'll get to later. But for now, just know that you cannot do that. If you try, it'll just give you an error. All right. So we have 2 minutes. So I'll just repeat what I said before, and we'll start with this again on Wednesday. So you can have this. So this is the kind of thing that we saw before. So you can say, get me the address where A lives and store it in PA. That's kind of the same. That's saying, tell me where A lives and store it in S. So S is of type char star. Again, char star is the type. It doesn't matter that it's like this, like char star is the type. This is the new thing. You can say, go to address PA and put the value 43 there. The way you do it is you say star PA equals 43. This star is not the same as this star. This star is part of the type. This is char star. This is what's called the dereference operator. This is saying go to address PA. It's a subtle distinction to which we cannot do justice in 1 minute. I will see you on Wednesday. Nice seeing everyone. Oh yeah, I had one more thing to show you. Anyone here from Vancouver? I know. So I was in Vancouver last December, and I went up Browse Mountain there. So it's like a mountain with stairs. And that's a sign that they have there. So I thought that was fitting.
That's good. You click with the memory layer. So let's say you find one as a chart.
Yeah.
And then can you replace it with like an integer? What do you go 60 per base?
I mean, so you cannot so a car takes less space than an integer. So
You can't like override it.
well, no, because like an integer takes more space. Now, if you can, so the float does have the same amount of space as an integer, so that you can in principle.
So the data type, it's not like it's just between the 5 by 5.
Yeah.
Yeah. Sure.
Okay, so go
Yeah, yeah, we'll do like much more of that. Don't worry. Yeah. Yeah. At here, yeah. Alright. Okay.
So the problem is word the first letter of the string.
No, it's stored every, so the variable prop has the address of the first string, yeah.
Where are the other